let's solve this question next. A very interesting version of a pretty complicated question in itself. The expression that I would require, let me recall that expression. Tan 3 theta is equal to what? You remember the formula of tan 3 theta in terms of tan theta? Just remember that. This is 3 tan theta minus tan cube theta over 1 minus 3 tan square theta. This is required, right? Where did you get that idea from? I got that idea from using this 3x x cube, 3x cube, right? Focus on the x, not on the a. A is a constant. We can always multiply, divide by a and simplify that expression into something else, right? Convert that expression as well. You can observe carefully that x is less than this, greater than this. X lies in some particular interval, yes. A is greater than 0 and you have to convert this in terms of tan inverse. So we'll require that. Okay. What kind of a substitution are we looking at? We are looking at a substitution where x upon a is tan theta. Where x upon a is tan theta, or let x equals a tan theta. Let x equals a tan theta, which implies theta is equal to tan inverse x over a. It is also given that minus a by square root of 3 is less than x is less than a by square root of 3. From here I can get the range of theta. Which is important for finally writing the final expression. This will give me x upon a. Let's divide with a. A is positive, so sign of inequality will not be affected. A is positive, so sign of inequality will not be affected. X upon a. Now take the tan inverse. X upon a, which is actually theta, is less than tan inverse of 1 by root 3. Which will, what is that? This is pi by 6 and this is minus pi by 6, right? Those are the values. Okay. So these are the values of theta, yes. Now I can focus on further solution. What's that? Further solution? I can simplify that expression. Let's try to do that. Tan inverse of 3 a square x minus x power 3 over a power 3 minus 3a x square. Can we divide by a cube in the numerator and denominator? Yes. What will happen is tan inverse a cube. You divide by a cube over here. A square gets cancelled. A remains in the denominator. Minus x by a power 3. A cube upon a cube is 1 minus 3. A gets cancelled. X by a whole square. This is what you get. Is that okay? Yes, that's okay. 3 times x by a minus x by a whole cube upon 1 minus 3 times x by a whole square. And this looks pretty similar to that one where x by a can be further substituted as tan theta. We have done that, right? So this is tan inverse 3 tan theta minus tan cube theta over 1 minus 3 tan square theta, since x by a is tan theta. What is this equal to? This equals tan 3 theta. Yes. So this becomes tan inverse tan 3 theta. Now what happens next is, what is tan inverse tan x equal to? It is equal to x in the interval, when x lies in the interval minus pi by 2 to pi by 2. This is theta, right? What happens to 3 theta? Is less than pi by 2 greater than minus pi by 2. Yes. This is important. The condition was given in such a manner that you can simplify tan inverse tan 3 theta in terms of 3 theta, because 3 theta lies in the interval minus pi by 2 to pi by 2. Is that okay? Yes. This is 3 theta. Okay. And what was theta? Theta is tan inverse x by a. So this is 3 times tan inverse x by a. And that's the simplest form of this expression, as you can see. That's the final answer. Yes, that's the final answer for this question. Let me get aside so that you can take a look at the complete solution. This is the formula that we have used. Otherwise, the solution is this, right? That's all.